So in our first example, we sketched a rose that was a trig function that was a sine, and now we're going to focus on a cosine, which means now we have symmetry with respect to our polar axis, which means like this. Okay, so we're going to say polar axis. And what that means is one of our petals is going to fall on the polar axis. So that's what we need to figure out. And that's kind of good for us. So what we're going to look at is the number of petals. Okay, so the number of petals, remember, is based on the coefficient of theta. So in this case, we have an odd number, which is 3. Okay, and then the length of the petal is based on our A value, which is all the way in the front. So now we're color-coded, and you can see, so this is going to be 5. That means the distance, okay, is going to be 5. Not the distance between the petal points. The distance between the petal points is going to be 2 pi divided by the number of petals, which in this case is odd, so there's no reducing. And then we'll have to figure out what our petal point is in a few minutes. So again, our values are going to change now because we are going to find values for 3 theta. Okay. And we're going to plug these in. Now they're going to be different for cosine. So for cosine, remember, you want to pick angles from the unit circle that are going to give us whole numbers like 0 or 1, or fractions like 1/2 and -1/2. So in this case, we're looking at 0. Remember, it's based on the symmetry. So in this case, we're going to do the upper half, whereas before we were using our basically our y-axis, and we were picking values on the right side so that we could plot on the left with symmetry. So now here, we're going to pick 0. And you need to pick an angle in here that is going to give me a fraction without a radical. So that would be pi over 3. Then we're up at pi over 2, because remember the cosine of pi over 2 is 0. Okay, and then we'll pick 2 pi over 3 here, and pi. So you have your points, 1, 2, 3, 4, 5. And what we're going to do with these points is plug them into our polar function here. So we have r is equal to 5 cosine of 3 theta. Okay, so we're picking or plugging in our 3 theta values, these right here. Okay, so now we have r is equal to, let's see, 5 cosine of 0. So this is going to be 5 times 1, or 5. So actually what's happened is, because this is a length, we have found our petal point. And we'll talk about that once we get our theta values. Okay, so here we have 5 cosine of pi over 3, which means I have 5 halves. But to help me plot, we'll just say 2.5. 5 cosine of pi over 2. So that means I have 5 times 0, so this is just 0. 5 cosine of 2 pi over 3. Now remember, in the second quadrant, cosine is negative. So this is going to be 5 times -1/2, which is -5/2, or -2.5. And then the last one would be 5 cosine of pi, which is -5. Okay, that's not a petal point because it's negative. Okay, the length is 5. So now, remember what we do. We're going to take 3 theta is equal to 0 and solve for theta. So we're dividing by 3. So this is 0. Then here, we're essentially dividing by 3 or multiplying by 1/3, so this would be pi over 9. This would be pi over 6. This would be 2 pi over 9. And this is what, pi over 3. Okay, so these are the points that we're going to plot. And we also, like I said, found our petal point, which is at 0. Okay, because this is the length. So you write the angle, or theta, where it occurs. Okay? All right, so now what we want to do is start plotting. So we're at 0, we're going to go out 5. So this is 1, 2, 3, 4, 5. Plot right here. This one's done. Okay, pi over 9. So the idea here is, where is this? If we know that this is pi over 6, if you get a common denominator with 9 and 6, we've got 18. So if I know, if I change this denominator and say, okay, this is equivalent to 3 pi over 18. And then with pi over 9, I get a common denominator. So pi over 9 would be the same thing as 2 pi over 18. That means 2 pi over 18 is going to be just below that. Okay, so when I plot this point, that's how I can figure this out. If I plot this point 2.5, 1, 2.5, it's probably really close. So 1, 2.5, it would be about right here. Okay, so that's this one that I just plotted. So we plotted this one right here, this one right here. Okay, and then we have at pi over 6, we're at 0, so it's right here. This is pi over 6. And then 2 pi over 9, which is 4 pi over 18. Let's plot this one, pi over 3 and negative 5. So 1, 2, 3, 4, 5. So it's going to be out here, 4 pi over 18. Well, let's plot this with respect to symmetry. So that means if I have 3, this one would actually, if my symmetry is here, I would plot this about right here. It's about right there. Then we're dealing with my pedal point, so this is 0. Then I'll be at 2 pi over 3, 1, 2, 3, 4, 5, and I got that by adding here, and then when I add again, I'm at 4 pi over 3. Okay, so then we have symmetry. So if this is my point, see how far away that is. So this is going to be at 2.5. 1, 2.5. This is an approximation. And then, is that right? 2.5. Yep. This is symmetry right here. So there's my 2.5. And then I'm dealing here with my symmetry as well. So 1, 2.5. And then it's also going to be right here for symmetry. Okay, so here are my 3 petals. 3 petals. I'm going to draw this to the best of our ability, like this, this, and this. Now maybe before I drew in pen, what I should have done was taken a look and double checked myself. So let me change this window again. So this is going to be 2 pi. Okay, graph that. That's my old one. Okay, so go back into y equals. Let's change this to 5 cosine theta, 3 theta. Graph it. That looks about right. Okay, and now we want to restrict our domain. So this is what we're looking at, restricting our domain. So I want to highlight on the graph with our restricted domain. Oh, pi to 3 pi over 2, using your calculator, this one says. So I'm going to go into my window. I need to change that to pi. And I need to change this, oops, clear, 3 pi divided by 2. Okay, graph. Oop. All right, look at that. So it's this full petal and only the top half of this one right here. Okay, so I need to highlight that. So this is just based on my calculator, which you will be able to do. Done.